Alright, welcome back. So today we have on the bench a 27-inch K7500 medium resolution chassis. This is the fourth and final chassis that I got in the series of 4 from the same operator. So I have not taken it out of the bag. It's all folded over, and I did see that there's a tag here that we'll get to in a moment, but I have not taken it out of the bag, so I have not inspected it. We'll share the knowledge of what's going on with it together. So having said that, let's take this out. Okay. ESD bag aside. Well, what are we stuck on here? There we go. Someone's got hot glue right here for some other reason or another. There's some hot glue sitting there. Can't say I've ever seen that before. Probably to try and keep. Is there hot glue on? That's not hot. There's no hot glue on the rest of them. Probably trying to keep this from moving. And I mean, hey, if it works, it works. Yeah, everything's oxidized and burned and everything back here. We'll have to fix that. But the traces seem intact for the most part. Yeah, they're wiggling around. But for the most part, yeah, I think a good reflow can get this up and going for the way that it is. Not too damaged, but very common. And this is all tied up. Let's just go ahead and remove all this here. Just get it out of our way. Okay, there we go. Yeah, the normal things here with this. Fixing all this solder. Actually, I never even checked here. It says caps changed November 8th, 07, good chassis. Well, I'll be the judge of that. Thank you very much. But yeah, another one that appears to have been sitting. I mean, obviously, if they changed the caps and marked the date and never put it back in the machine, I don't know why this would even be here. Maybe it's, I can't say, but I'm going off the idea that this has been sitting in that bag and on a shelf somewhere with the other 3 chassis since at least 07. But it's got original caps, it looks like. We'll get to that in a moment. These are all original, I can tell you that from looking at the board. And otherwise it's not too bad. Let's put all our pots to center. They're kind of already centered at the moment. That one was kind of hard to turn, suspect of that one. This one's kind of burned up a bit. But otherwise, oh, someone's got R500 lifted out of the R500. That's why it's important to inspect this stuff, boys and girls, is someone's got R500 lifted out of the board. Now why that would be, I can't say. It looks like it's always been that way. This looks untouched, that solder joint. There's no flux around it. There's no hole like it came out by accident. It looks like it's always been removed. Now why that would be like that, I can't say. So I'm going to actually put that back in, and we'll see if that does anything. But we'll take care of that. As a matter of fact, I have a spare neck board that I used to rob on the U2000 video prior to this one, where we had the bad green transistor. I have a spare neck board here that's complete and working. I didn't have any of these transistors on hand, so I actually ordered some, but in the meantime I robbed it from here to get that other U2000 working, and I'll replace this one later. But you can see here that resistor is completely installed and intact on this board, so I don't understand why this would have one leg removed. I think maybe it didn't get soldered in from the factory and no one ever noticed it, and it may not be that crucial. I can't say for sure, but we'll get it reinstalled. Otherwise the neck board appears to be in fairly decent shape, and we'll have to do all of our rework on here, but no big deal. Okay, so there's the neck board, main board. Let me say for a minute here that the 27-inch K7500 and 25-inch K7500 are actually identical. There's actually no difference between the 25-inch version and 27-inch version except for this little pincushion board. When you're increasing the size from 25 to 27, it has a tendency to kind of round itself out or not be square anymore, and this is designed, this little pincushion board is designed to counteract that. You can actually adjust your round pincushion issue or make it more square or less square, whatever you want to do with this pincushion board. And this is for the 27-inch. According to my experience and my research and everything that I've ever come across with these 25 and 27-inch 7500s, this is the only difference that's been documented that I've been able to find over the years that denotes between 25 and 27. So we'll just set this aside for the moment. And of course it just plugs on these little header pins right there. But overall it's fairly clean. I gotta say it's got to be a high usage chassis because the protective plastic piece here is burned or heat damaged, as well as the excessive heat damage or heat on the actual neck board here. So it may not be that high a usage, but it's definitely got some usage behind it. It does appear to be complete. Linearity coil's intact. Everything looks good. The Q603, I think it's 603, 703, Q703. I always forget. I just did the last one. I think it's 703. Yeah, we'll call it 703. This little power transistor here that will keep the board from powering up at all and be totally dead if it's bad. It's got the heat sink on it, and it's standing straight up, and it's not loose. So that's in good shape. Usually you see them bent over or messed around with because of the heat sink will cause it to get bent back and forth. You can have broken legs and other issues. The caps are absolutely original. It's got all of the glue still on them. You can see the glue still on the cap there. This is that 50-volt bipolar cap that's got the glue. All of these, oh well, maybe not. This one's been changed and this one's been changed. But that one hasn't and this one hasn't. Well, you see that quite often from the operators. See, this one has not been changed either, right there. They change whichever ones need to be changed in order to get the chassis working, and that's all they need. Well, I just noticed something. What is going on here? What in the heck? Ooh, that resistor burned up. Ouch. Holy cow. Looks like the original R302 burned up, and they didn't have the correct one on hand, so they put this monstrosity in here. I may replace that. Actually, I think I will replace that if I can find the correct resistor. I'm going to replace that and get it fixed. This makes me wonder about vertical collapse, because I think this resistor is part of the vertical collapse problem, or is part of the vertical circuit. But we'll check it out, see what's going on with it. That's odd. Yeah, so strategic cap replacement, questionable mods. Everything else appears to be okay. Let's look at the back side. Let's ditch this too. There we go. All right. Gosh darn it. There we go. Okay, backside. I don't see any butchery. We're gonna have to reflow some of these solder joints up here in the high heat area where that piece was discolored, right around this area here. So we'll take care of that. Not a big deal at all. Looks fairly good under here. Not too bad. Alright, so I guess what we'll do here is we'll start with testing everything like we normally do. Get rid of our... Oh, I almost forgot like last time. Let's inspect our remote board. Make sure we don't have any broken pots. This one's smashed kind of flat. Okay. Readjust that. And otherwise, yeah, they look okay. So we'll set that aside. And yeah, that seems okay. Alright. Well, let's get to testing, and if everything tests okay, we'll go ahead and fire it up to see if it actually does work and how it looks. And I actually have a cap kit. If it actually looks good and doesn't need any kind of repairs, then I'm just going to do the cap kit and everything else off camera, because there's not really any reason to do that and then show it again if it's not going to look any different. Just doing the cap kit for preventive maintenance is really all there really is, the idea behind that. But if we power it up and everything is perfect and beautiful, then I'll just do the cap kit and everything else and all the other stuff off camera. But if something needs repaired, of course, we'll do that and show that. But first, what's important here is to actually make sure everything is good. So, like last time, we will start with the power supply section again, R104. Oh, I wanted to show you. I forgot. I've mentioned this before, but there's no reason not to do it now. How you can tell the difference between these chassis is there's an ID tag right here by R104. You see here it says Wells Gardner Manufacturing 27-inch 7500. So that's how you can tell on these. It'll say WGM 2574 for 25-inch 7400. The U2000 has a different sticker here, but the U2000 is the only one that has the horizontal width coil right here. If you just look at this chassis and you don't know what chassis it is, and you see the horizontal width coil right here in this location, the U2000 is the only one that has the coil right here on by the HOT. So if you see it by the HOT, it's absolutely a U2000, and I say that because the U2000 has a different sticker on it that doesn't say this. It's got some gobbledygook numbers on it, and it doesn't actually say. Well, I take that back. Some of them do. But a lot of them will just have a gobbledygook number on here and you won't know what it means. Some of them do say WGM 2520, but in my experience that's a rare occurrence. Most of them have a nonsense number here. So I wanted to point that out. That's how you can tell what these chassis are, is that the U2000 will have that horizontal coil in that one spot. That's the only one that has it. The rest of them have it here in this spot or around this area. But otherwise you can look at the sticker here and it'll tell you what it is. So let's actually test our R104. Should be 10K, 12, sometimes they go up to 13, but with it being 12.8K, it's actually okay. I'm not worried about it. But that, again, that indicates that this area here should be good. If any of the other stuff in here was bad, this wouldn't read, well, I say correctly, but it wouldn't read the 10K. So that's all okay. We can check our voltage regulator. See, here's how it should be. I mentioned in the last video that someone had kind of not installed it properly. It's supposed to be a through-hole component, like it is here, through-hole component, and then there's a little bracket here that it mounts to that keeps it flush against the heatsink. But let's go ahead and test this, and we should get voltage drop across one lead, and then I think it's 1.0 across the other. I think this should be the voltage drop pin here. Nope, sorry, diode setting. Yep, there's our 0.5 drop. The other one should be 1.0 something or other. Yep, perfect. Voltage regulator is good. We can test, let's see, voltage regulator is good. R104, let's test our switch mode power supply chip. Alright. These two pins here should be diode, yeah, and diode, yep, 1.0 and 1.7, 1.9, close enough. So alright, our switch mode power supply chip reads good, so that shouldn't give us a problem. Q703, again, this guy here, if this is bad, it will be totally dead, so we'll check that. And I always just go to black lead on the center and red on each end, 0.6 and 0.9. That should be good. Again, you're just checking to make sure it's not shorted or open, and you get the voltage drop like you should. So there we go. That should be good. Okay, we can test R303 to make sure we don't have vertical collapse when we turn it on. Should be, I think, 1.5. 17 ohms. That is way out of tolerance. Well, no wonder this burned up. This should be, I think, I think the maximum you can have on this is 3 ohms. I mentioned in the last video that 3 ohms is the norm. It was 1.5, which is actually good. So I actually think 1.5, between 1.5 and 3 ohms is what R303 should read. But if we look here, it's 17 ohms. So that's not good. In all likelihood, this would work with 17 ohms, but you'd have vertical problems. I'm going to have to change that out because that is not right. 17 ohms is not right. So let's check D302. That should be good. Can I get to it? Okay, D302 is good. If D302 is open, or R303 is way out of tolerance, you'll have vertical collapse. So those are important parts to check. And also D603, again, this little guy right in here, D603, it should only read one way. If you read both ways across the diode, the vertical IC is bad. So that's something important to test as well. Let's go down here. And I always repeat these same things in all these videos because if someone's coming into these videos fresh and they haven't seen the other ones, it's a good refresher for me, and it's so they know what's going on without having to watch every other video I've done and go through and hunt and everything. So I'll always go through everything on each video for the people coming into it new, or as a refresher for other people coming back to it later, if you will. So, okay, should read this way as the diode, correct. Let's flip our leads and test it the other way. And it's good. So we shouldn't have vertical collapse, but that 17 ohm R303 is not good. We'll have to change that. So now I'm interested to find out what this monstrosity here reads. .8. I don't know if that's correct. I'll have to use another chassis for verification. I have a 27-inch complete. I have a complete 27-inch 7500 monitor, so I can pull that chassis off that tube and compare what this is supposed to read and see if that's correct, because I don't know offhand. But in all, just for the sake of testing, because we shouldn't be collapsed, even though R303 is 17 ohms, it should be 1.5 to 3. We shouldn't be collapsed based off of the fact that it's 17 ohms and not way in the mega ohm, and everything else seems to be good. So based off that, I'm still going to power it up just like it is here and see what we get, what it looks like, just out of curiosity's sake. So let's test our HOT now as the last component. Where are you at? Hiding right here. HOT 0.5 and oh, come on. There we go, 0.5. Well, everything tests good. Everything looks okay. Nothing that needs reflowed immediately that I see. That's lifted up a bit. Still can. We got a resistor here. That resistor that gets hot, you can see here that it's right here. The pad is lifted, but the trace isn't broken. So I'll fix that. But the trace isn't broken, so we can leave it for now. So I think we can go ahead and just, since everything is tested good, I get kind of disappointed when everything tests good. I get kind of disappointed because it doesn't make for a good video. Just testing and turning on everything's fine, but at least it's a little bit educational for those coming into this fresh, as I said. So let's go ahead and just get it hooked up and see what it looks like. There's no real reason not to, since everything tests okay. I can put this back for now. I'm gonna need it to hook it up. I guess before we do that, let's make sure that this isn't going to cause a problem. Everything is, that solder is just absolutely heat damaged and oxidized. It's real bad here. You can see like all of these traces here, all these. Can I go further? That's a bit better. Yeah, it's just on the absolute cusp of not being good. So this will all have to be reflowed. But for testing purposes, it should work. So let's go ahead and see what we get. I'll grab the tube and I'll get the other chassis off the tube, and I'm going to go ahead and check this resistor on that one to see what it is, and I'll let you know if it's accurate or not. And in the meantime, I guess we can hook all this back up real quick. And I only unhooked this so it's easier to drop the pincushion board. I only unhooked this to make it easier to handle this while I'm turning it upside down and around and things like that. Alright, so we're hooked up there. Let's get our focus wire in there, make sure it doesn't bend on itself. Close it up. Fold it around. This was never folded around either. I can tell from the memory of the wire. That's how it should be, folded around there. G2 wire. Okay, so that's everything for the neck board. And let's get our pincushion board hooked back up. Not that you don't really, honestly, even really need this, but that's the only real difference between 27 and 25. So I'll hook it back up just for the sake of completeness. All right, I'll go grab the tube, get the other chassis off of it, and get this one on it. Test that R, what was it 402? Was it 402? Yeah, R402. Make sure it's supposed to read 1.3 or 1.2, whatever it was. If it is, then we'll just go ahead and hook it up and turn it on and cross our fingers. Give me a moment. Alright, so real quick, this is the chassis that came off of the tube we're going to be testing with. The one I've already rebuilt and is working great. So let me show you here. This is what R402 is supposed to look like. Right here. And if we test it, it reads, let me get a good contact on it, 1.8, 1.7, 1.9. Now that is corresponding to this one that we're going to test here with this weird setup. 1.8, 1.9. So given that, I think I'm going to leave that in here, because if it's reading what it's supposed to, and obviously they got the necessary wattage in there, I'm going to leave that. But if we look at R303, like I mentioned, let's see, get this out of the way. This guy right in here, it reads 17.1 ohms. Now if we go to this other one that is working, just as a reference, I'll show you. R303. Get in there. 1.2, 1.1. So that's what it's supposed to read. So I'm very interested and curious to find out. I need to do something better with those. I'm very curious to find out what our image looks like if we're squished or if we have vertical issues using this 17 ohm R303. So join in the knowledge with me. Let me get the tube over here, get this on it, and we'll see what it looks like. Okay, we're all hooked up. Anode, neck, yoke, ground, video, power, remote board. I think that might be it. So we have our test pattern generator. The 7500 is medium resolution only, so I have to use my test pattern generator. We have it set to medium resolution. Let's go ahead and turn it on, and we'll see whether or not this is in fact a working chassis, as the tag denotes. 1, 2, 3. It does indeed power up. Do we have... And just as I suspected, partial collapse. That's that R303 problem. Let me get the camera on the tripod, see if I can get a stable image here. Let's adjust our hold. I can't get a vertical hold stabilization here. Let's do our horizontal hold. I have to adjust it with the driver here. There we go. There's horizontal hold, vertical hold. Got it. Okay, contrast. brightness, screen pot is right there, contrast, brightness. Well, yep, absolutely 100%. That 17 ohm R303 is causing this problem. It's folded over on the top, it's collapsed. So let's get that R303 replaced. Let's see if we actually have our width control. We do not have width control because I have the transistor plugged in upside down. Can I flip this around the other way? Will it let me do that? Yes, it will. And now I have width control, and I'll explain that in a moment if you're unfamiliar with that. Right. Yeah, okay. So the K7500 has the width control transistor mounted remotely, and you have to, well, it's getting worse. I'm going to turn this off. I'll show you here. So there is a transistor mounted to the frame here. It's right here. This is normally mounted right here on the other models like this, but for some reason they remote mounted over here to the frame. So if that's not hooked up properly, you saw there I was not able to control my width. I had it actually installed the other way around. It has to be plugged in this way. I overlooked that. I did plug it in, but I had it upside down. So this has to be plugged in or you will not have your width control. And if you have one of these that's missing the transistor, you'll have to get one. I'll see if I can remember. As a matter of fact, let me see if I can read the part. Nope, it's not on this one. I was going to see if I could read the part number off of it. Actually, I probably could. Let me turn this here. Get it on camera there. What's that say? SEC 530 B0X53 Charlie. Yeah, it's hard to say. But there is what it says on the face of it. But that transistor is absolutely necessary for you to have proper width control. So, all right, well, let's turn this off and get this removed, and we'll replace that R303, and I'll bet you that'll fix our problem. So stand by. All right, so R303 has been replaced. You can see there that I've got a couple of clip leads. Get out of here so to focus here. Get out of there. There you go. So it's been replaced. You see I got some clip leads on there that are running over to my meter leads, red and black, and it reads 1.8. So that's good. So R303 has been replaced, been changed out. It reads correctly. So now let's go ahead and get rid of these. I only have these on here because I can't do this with one hand while trying to use the camera. So do it remotely here. All right, so let's get these out of the way so we don't touch something, and let's test this one if I can. It's not going to let me. I don't know how I'm going to do this with one hand here, but I wanted to show you what this one reads out of circuit. And it's actually higher than what it was. I don't think I'll be able to do this. Come on, come on. 18.2. 18.4 was 19.1 earlier. Probably because it was still slightly hot from taking it out. So, yep, definitely bad. So let's cross our fingers here, and I'll bet you that we are good now. So let's set this up. And, oh, I need my test pattern generator. Okay, medium res, turn it on. I need my power. Okay, alright, here we go. Focus up, focus up. There we go. Oh, we still got some fold over, probably because it's set too high. Vertical size is probably set too high. Let's see, vertical size, height. Oh, no, we still got problems. Because this is folding over on itself. But I'll bet you anything, this is cap related. Because the caps are original. So now that we have a full image, R303 was definitely the problem. Very common. You can see on the top here we have those lines, and they follow the image. If I bring the vertical size down, you can see that they go away, and there they come back. So it's not folding over on itself, but I can guarantee you that the caps around the vertical IC are probably bad, or it could have something to do with those other resistors that were in there that were kind of in parallel, attached in parallel. But I don't think so, because it's reading correctly. I think, whoa, they're going away. They're actively going away as I film. That's absolutely a capacitor problem. If we lower, yeah, they're completely and totally gone now. That is absolutely 100% a capacitor issue. Because as the capacitor charges up or discharges, those lines will start to fade. So that's I've never seen something like that happen or able to capture it on camera like that, but you can see they're actively gone. If I turn this off, let me turn this off, and I'll count to 5 here. Or let's count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they came back, and now they're gone again. They came back there. If you saw, they were there very momentarily, and then went back. So yeah, we have a fully functional working K7500 27-inch, and it looks like I'm going to have to do caps because we got some bad caps. But after they warmed up, those lines went away. Very interesting. So let's review here. We've got bad caps, which I can change out, no big deal. Like I say, now that we have a fully working, good, stable image, I'm not going to really bother showing the cap kit on camera before and after, because it won't look any different than this. But we have bad caps. We had a bad R303. And was that it? I think that was it. We had a bad R303 and we have bad caps. So let's scroll through here, make sure we have RGB. We do have RGB. We need to do some reflow on the neck board. I may show that. But we have beautiful RGB. And everything looks great. Full image. We've got, I need to throw some convergence strips in here because the two corners are kind of bad and it squished a bit on the bottom, but that's probably caps. But we do have a complete full square image. So as far as geometry and everything goes, it's okay. And I'm going to show you here that if I'm just going to remove the pincushion board right off the chassis while it's powered up. And you can see how it kind of bows inward there. You can see how it kind of bowed inward on the edges along the side. Now if I hook this back up, if I'm able to, so you can see how the image changes. Now it's back to square. So the only real difference between 25 and 27 inch is that pincushion board. But for all intents and purposes, yeah, we're basically done with this. I am going to do all the reflow, rework on the neck board. I'll show that on camera just so you can see it in action. But I'm not going to turn it back on afterward on camera because it'll work just fine. So there we have it. 27-inch K7500, fully operational after changing out R303 to fix the collapse. And we had the kind of fold over on top because of bad caps. So let's get the neck board repaired, and then that we'll call it, I guess, let me rephrase. We have the neck board repaired and we can call it from there. I don't have the best narration. I don't make cuts because there's no reason not to just keep all of my silliness and my crazy way of talking and things on camera. There's no reason to edit that out because I don't care. So, but yeah, here we go. Another one successfully repaired. So I'll get the neck board off and we'll get that checked out and repaired as well. And then we'll call this a video. So one moment. Okay, so let's get this fixed up. So a lot of people actually refer to reflowing as just adding new solder to what's existing there, but that's not actually correct. The correct phrasing or the correct nomenclature of reflowing would be to remove the existing solder and reflow new solder. So that's what we're going to do. We're actually going to take all this off of here and reposition these so not only are they going to be flat as opposed to being bent over like that, but they'll also be more secure and better connections. So as well as these resistors get very hot as well, and you can see that even those have broken pads very slightly here. You can see right there that it's a broken pad. Maybe you can't, but I can. So we're going to take all this original solder off of here, and we're going to flow new solder onto it. And that should be all this really needs. The traces themselves aren't really too butchered, so I'm not going to have to do all the trace repair like I normally do, you know, scraping off the solder mask and with the fiberglass pen and soldering right to the trace. We're not going to have to do any of that because this stuff's actually not that bad. Alright, so there should be one. No, not quite here. There we go. Let's get this off of here. Okay, there's one. Okay, let's start with some fresh here. And I'm using the braid as opposed to the desoldering gun because this solder is so old and heat damaged and oxidized that it's just easier to use the braid than it is to use the desoldering gun. There was hardly anything left on that one. This should come right out. There it goes. Easy breezy beautiful cover girl. Yeah, these were barely hanging in there. Let's get this one out of here. Oh, this one's glued in place here. There we go. All right. Let's clean this up a bit. Okay. Now for our resistors here, I'm going to remove those as well because the solder on these is very oxidized as well. All these here, can I zoom in and see that? Yeah, all of this stuff here is very oxidized and needs to be reflowed as well. And these here are going to have to be repaired because of the lifted pads there. I don't trust that, so yeah, we'll have to do those as well. Not a big deal at all. Okay, out, damn spot, out. Now let's go ahead and just pull these out manually. Alright, what I'm going to do here is get rid of the solder. And break out the fiberglass pen. And we'll scrape some of this away here. So there you can see that works fairly well, and then we'll end up just filling these with solder to help this connection and they don't break off anymore. So that should work for that. Yeah, as far as everything else goes, though, I think we can. I mean, the traces aren't that bad. You can see that they're lifted a bit, but they'll be stable once you get all the transistors back in. It's not too bad compared to how they used to be. Alright, so what I like to do is put these back in. Let's start with the inboard one here, the red one. And make sure that sits flat on here. Flat as it can be. There you go. You don't want it resting on top of that inductor there. Let's grab my pointer. You don't want it resting on top of the inductor or the resistor. You want it kind of laying flat up against it. So you want this as flat as can be, where it's not resting on top of these two components. So now that that's installed there, ooh man, well, I lied. Those are lifted quite badly. I just didn't notice because they weren't on there. But I think it'll be okay. Alright. Where's my... Oh, it's outside, darn it. Let's grab this instead. Alright, that should be okay. That should be alright. And there we go. I think that'll be okay. Yep. Nice and solid. I'm not going to go too hard with it, but yep, nice and solid. And traces don't lift. I think we'll be just fine. So that's one down. Zoom back out here. And we'll do the other ones. Let's make sure we don't make the pads worse here. Got it. Okay. Make sure we're not sitting on top of the inductor or any of the other components there. And we're sitting flat, just like it should be. And let's solder this one in. Alright, I think that'll work. That'll do, pig. That'll do. And that one went right in as well. And we'll have to, oops, sorry about that. Make sure we're not sitting on the parts. There we go. And push it flat. That will suffice, and they're all sitting good now. Sometimes these pads will be oxidized to where solder won't stick to them. If that's the case, you want to remove the original solder and clean the pad off with your fiberglass pen or any other method you want to use, but you want to remove the oxidation off of the pad so you can solder to it. And there we have it. So those are done. And you'll see that they're not sitting on the components, they're nice and flat, give or take. Obviously this is the one that used to be here, but it doesn't matter, they're all working. Doesn't matter what position they're in. This is the red, green, and blue because it corresponds to red, green, and blue. So that's what those are. And Let's get our resistors reinstalled. Is that gonna, that will give me an issue here. Get out of there. Okay. Okay. And line that up. And it should flow quite nicely onto here. Well, if it didn't fall out, you bastard. I guess we'll do this side first then. Alright. Now we can go to this one. Well, that leg is oxidized a bit. There we go. That should do it. That should do it. Beautiful. So there's one, nice and secure. Don't have to worry about that getting loose on us. Go through the next one here. Well, that one is fighting me because there's solder stuck to it. There we go. Okay. Get rid of that. That's better. Okay. You know what? To make this easier on me, I'm going to clean these off of here. Clean these legs to get some of this oxidation off so the solder sticks better. Alright, of course, you little, that's the one that was lifted. There we go. Okay. That's good. Let's go to here. And it's still oxidized. There we go. I just realized it's not even on camera. I have a habit of zooming in and then losing you. Sorry about that. But you can see here that we are good now on both ends. So let's get this last one in here. And we'll get this one done. Oh, I pushed it. I was trying to go sideways with it and I pushed it. There we go. Sometimes you can use your soldering iron to kind of scrape away oxidation and whatnot. I forgot to. I'll be damned if I didn't forget to. We're going to take this back out. I forgot to clean the legs off of this one. If you got a problem with solder sticking to your component leg, you got to get rid of that oxidation off of there. Then it should flow just fine. Okay, that's back in. Let's try round 2 here. I'll bet you it's much easier now. Well, if it stayed in there. Sorry about that. Give me a second. All right, here we go. quite sure what's going on there. It does not look good at all. So we're going to redo this. Too much solder is also a bad thing. You want it to look like a nice good shiny joint. That's better. Really? Come on. There we go. Well, not beautiful, but it will work. Okay. It's not always about the aesthetics, but you want it to look good as well when you can. Alright, so I do believe we are good to go. Let's zoom out and give everything else a look over. Yeah, seems okay. Let's hit these real quick. These are the neckboard headers for the connector that feeds down to the actual PCB. Okay. Those look good. So I think we are about done. We got everything evenly spaced. Everything's, oh, sorry about that. Evenly spaced, set flat, nothing's touching. We got our resistors spread out so they don't induce heat on the other ones. So that'll be it. I'm going to do a cap kit and probably call this one done. I haven't decided if I'm going to show it off afterward, but I'm quite interested to see that with this chassis being powered off for the hour that it takes for me to do the cap kit and back on, if those lines come back and slowly fade away. If they do, then I want to troubleshoot further, but I'm 99.9% sure that those lines showing up and then fading away like that are absolutely a cap. So I'm going to do a cap kit, and I may or may not come back. If I don't, just assume that fixed it. If I do come back, I'll show that it's fixed it, and we'll go from there. Alright, so obviously I've decided to cut back here after getting everything reflowed and full cap kit, just to make sure I didn't put any caps in backwards and it powers up and there's no issues. The main thing I want to find out is whether or not those horizontal lines go away. I've had this off for about the last 4 hours, and between just a few moments ago when you saw me working on the neck board, prior to that and up to this point right now, this has been off for about 4 hours, 4.5 hours, give or take. And it should be plenty of time. Not only are all the old caps gone, and the full new cap kit's been installed on the main board and the neck board, but I also did the full complete total reflow of any and everything that needed reflowed. So full reflow, full rebuild on the caps. The flyback was working. It produced a nice good image, and it had no issues with focus. So the flyback is fine unless it starts drifting. I'll leave it on for a couple hours. Unless the flyback starts drifting in focus or drifting in brightness, I'm going to call it fine. I don't like to change flybacks just for the sake of changing them, because if the one that's in there is working fine, there's no reason to change it unless it goes bad. So yeah, full reflow, full cap kit, main board, neck board. There's all the old caps. Yeah, and it's ready to go. Let's turn it on. I have not turned it on yet. So A, we're going to make sure that none of the caps are in backwards, nothing explodes, nothing blows up. B, it still powers up. And C, if it does, to make sure those lines are gone on the top. Assuming that they will be, because we got all new caps in there. So let's turn the test pattern generator on.
And I got the fan turned off in case something explodes or pops or starts smoking. We'll be able to see and hear. So let's see what happens. 1, 2, 3. Hopefully it fires up and we get rid of our horizontal lines. Let's go. Oh, that was scary. It didn't turn on. It took longer to turn on than normal. That was scary. And yep, horizontal lines immediately are gone, just as I suspected. And the contrast is off from last time because I had to adjust the sub-contrast knob right there. It was turned completely down, so I set it back to the center. So that's why this contrast is higher than it was before. Let's turn it down. There we go. Yeah, no lines immediately after being off for 4 hours, 4.5 hours or so. So that the cap kit fixed that. I was absolutely correct on that. I knew that I would be. That's almost always an issue with that. So let's go through again and make sure we can adjust and get a good image and call this one fixed. That looks really darn good right there. Let's go with our focus. And let's get a different image, different picture up there. Beautiful RGB. Let's get this up here and okay, that's gorgeous. I don't think we have any more linearity problems like we had before. Let's do height. That's good. H position. Right about there. We have width control. We have width control. Perfect square stable image. I gotta say, it's good to go. So alright, thanks for watching. I'm glad you tuned in, stayed all the way to the end here. It's about an hour long or so I think this is going. We're going to end up being at least an hour. So yeah, hopefully you learned something. Thanks for watching, and we'll see you on the next repair.